This might make a There's only weird noises. Okay. Let me try to figure this out. There's only weird noises. Okay. So it's got to be this. Better? I need it to only have my microphone catch. And I don't know if that's it yet. How is that? Okay, the volume thing is definitely a challenge. Are we better now? We may have figured it out. Yay! Hi! Okay, there is a delay. It's like a 5-second delay. So I can see that I'm typing stuff, but I already typed it a while ago. I don't like the delay. I need to change that for next time. Oh, wait. Let me see if I can do that now. Nope. Okay. Jennifer, thank you for helping me. And I don't know who else is here, but I hope that it's people in our class. Hello. All right. If it gets weird, or you can't hear, just text me, or not text me, wow. Send a message as we go. And I hope that in addition to Jennifer, we have a few other people in the class. This is actually kind of fun. All right. Okay, hopefully you can't hear the stuff. All right, so we are going to talk about formulas, the types of literal equations that we worked with in school the other day. And just to warn you, my dogs might go crazy because they bark a lot. And they are both on the lookout. So if anything goes near our house, there will be barking. Hopefully we can just keep going and not worry about it. I am going to keep the chat up on the right side for anyone that wants to comment or ask a question, or if you need clarification. And I can type there as well. And then I'm going to keep this open over here so that I can write on the screen and we can go over some stuff. So I'm going to start. If I see any questions, I will pause. But again, there is like a 5-second delay. So by the time you've heard this, I've already moved on. When I see your questions, I'll stop. Next time, I won't do a delay. I'll just make it live, so that we don't have to worry. Okay, so we talked on Friday about literal equations, and they were just equations that had variables in them, and the most common one that we work with is a formula. So formulas are equations that state relationships among quantities. Do we have any idea of the types of formulas that we use? You can comment if you know of any formulas that you've used, just to get like an idea of anything, whether it's geometry or algebra, any formulas that we're used to. And you can comment in there if you know of any. Even if you just know, like, one we talked about in class was like the area of a rectangle. So here's some other ones. These are some formulas. We have perimeter of a rectangle, the circumference of a circle, area of a rectangle, area of a triangle. So these are formulas because we know that we can calculate. Yes, Roxana, good job. The area of a rectangle is length times width. Good. We use a lot of formulas in geometry. So one of the formulas you see today is actually a formula that you'll learn later this year, because when we do geometry. So we're going to work with these formulas, and we're going to figure out how to rewrite them or transform them to solve for a specific variable. So let's first talk here about this problem, the radius of a circle with a circumference of 64. And we're going to round to the nearest tenth. So you may need a calculator for this, which is fine, because traditionally you would have a calculator to get your final answer. But let's go over here what we would do. So what formula, and you can kind of see the word in the problem, what formula do you think we need for this problem? What formula do you think? Give you a little hint. The circumference. So we're going to use the formula for the circumference of a circle to figure out what the radius would be. So here's our formula. That's the formula for the circumference of a circle. And this value here, C, is the total, your actual circumference. Writing on this with the pen is actually very hard. I have to get better at this. Wow, I'm really bad at this. Okay, that's the circumference. Pi, we know, tends to be 3. We estimate 3.14. And then the radius is what we're finding. We're actually going to find this. Okay, we need to isolate. So the key here is that we're going to isolate, and we talk about this a lot when we solve equations. We isolate our variable. So we need to get the radius alone. Okay, so do we know what's happening to the radius here in this formula? And there is going to be some lag time because of the delay. But if you know what's happening to the radius here, message it over here in the chat. And tell me what you know is happening, what operations are happening to the radius. Because our goal is we want to undo them. And I know there's 5 of you watching, so I see Jennifer and Roxana. If anyone else wants to comment so that we can identify what's happening to the radius, feel free to write it in the chat. There's one thing, like one big thing. It's getting multiplied. Perfect. Roxana, it is getting multiplied by pi. And the pi in math actually doesn't have an E on it, just a PI. What else is being, so we know that. So we know that that's multiplying by pi. What else is the radius getting multiplied by? because there's one other thing that the radius is getting multiplied by. There's one other number there. So I'll give you a little hint. We're also multiplying by 2. So our radius here is being multiplied by 2 times pi. So who can tell me, what do we do? How do we undo multiplication? I'm going to wait for someone to chat that in because I know you all know how we undo multiplication. To undo multiplication, what do we want to do? What operation? We divide. Perfect. So we are going, yeah, Shayla, welcome. So we're going to divide. So we can undo the multiplication of 2 times pi by dividing by 2 times pi. Okay. And if we do it to one side of the equation, we have to do it to the other side. And if somebody wants to type in why we need to do it to both sides, that would be great as I continue on. So answer that question. Why do we have to divide by 2 pi on both sides? And while you do that, I'm actually going to continue to write through our equation so that we see what it is. So we have C, the circumference, divided by 2 times pi is going to equal the radius. Okay. So this is perfect. We have our equation completely rewritten. Yes, great job, Jennifer. We need to keep both sides balanced. That's perfect. So we have the equation rewritten. Now we have our radius isolated. So now we can actually just substitute in the values that we know. What values do we know here? And the problem itself, the original problem, tells us the values that we know. So type them in. What do we know? And I'll actually start to work through because there's a little delay. We can change or substitute our circumference for 64. And we do know that pi we can use instead of the symbol, because that's a little tough. We can use 3.14. So now we have enough. Uh-oh. Don't bark. Talking to my students. So now we've substituted in enough values that we can calculate. So we know that we can rewrite this as 64 divided by 6.28. And if you had to do this with long division, you could. But if you wanted to do this with just a calculator, the radius here is approximately, and actually, you know what? I'm going to do this line. We're going to do that to show that it's approximately 10.2. So let's recap what we did before we try another one. All we're doing here is isolating the variable from this formula. We're told to solve for r, so we're going to isolate just like we do in a regular equation or in a one variable equation. We're going to undo every operation that's happening to the variable that we need. So in this scenario, we divided both sides by 2 times pi because in this formula, to find the circumference, you would multiply the radius by 2 times pi. So we're going to try a different one, a formula that you may be a little bit more comfortable with. Okay. So in this scenario, we'll try this example because a lot of us have worked at this point in our educational career. We have worked with the area of a triangle. So we're going to find the height of a triangle that has an area of 24 inches squared and a base with a length of 8 inches. Now the formula for the area of a triangle, and I'm going to put it here, area is, I'll give you the first part. Who can give me the second part? 1/2 times what? Who can tell me what we're going to multiply? To find the area of a triangle, it's the area is 1/2 times what? If we don't remember, that's okay. One half. I'm not a fan of the delay. I'm not going to use the delay next time. Anybody know what our formula is going to be for the triangle? 1/2 times the base times the height. So now we need to get our height. We want to solve this equation for our height. So what's happening to the height? Who can chat in? What's happening to the height? It's being, what's the operation? No. Oh, something outside. Okay. Well, our height is being multiplied by 1/2 and by the base. Okay, Hercules, in a minute. So in order to get the height by itself, we need to undo these operations. Now, we talked in class about what we can do when we want to divide. We can either divide by 1/2, or what we learned this past week, we could multiply by 2. Okay. And the reason I can do that is because we know that dividing by 1/2 is the same as multiplying by 2. So we now have 2 times the area, my A changed a little bit, is going to equal the base times the height. And here there's one more thing that's happening to my height. It's being multiplied by my base. So I'm going to divide both sides by the base. This becomes a big 1. So now our height is by itself. We're good. And I'm going to erase everything else since it's now gone. I'm going to have to rewrite my height. So now it's pretty easy for us to substitute in. We're going to substitute in to find if our value works. So we know that the area is 24 and that the length of the base is 8. So we have 24 times 2 divided by 8 should be our height if we did this right. And we know that 24 times 2 is 48. So 48 divided by 8, our height should equal 6. Now the best way to check this would actually be to go back and do the calculation that we know if we were trying to find the area in this scenario, is the area, which will be 24, is that going to be the result when I multiply 1/2 times 8 times 6? Because now we're saying that the height is 6. And the answer here is yes. 8 times 6 is 48. 48 times 1/2 is 24. So in this scenario, we know we have the right value. And by isolating and transforming this formula to get our height alone, it was much easier for us to substitute in the values that we did know. So again, the idea of a literal equation is not different than the solutions or than the solving that we're doing already. The difference is now you may not be dividing by 5 or multiplying both sides by 7. You may actually be dividing both sides by B or multiplying both sides by an A. And it's because those variables have different, they represent different things. So we're going to try one more. And this is the perimeter of a rectangle. It's 2 times L plus 2 times W. And really what this is, if I show you a nice rectangle here. So here's our rectangle. We have our length, our width, and our width. Okay? And our perimeter, just like we talk about in class, if the rectangle is a yard, the perimeter is the fence, the area is the grass. But we're just talking about the outside. So a lot of you would say we add up all the sides, which is correct. Length plus length, which would be 2 lengths, and then width plus width, which would be 2 widths. So this would be our formula for the perimeter of a rectangle. So now, let's say we wanted to solve this for L. We wanted to get the length. We are told in a scenario, we're told that the perimeter is 24. And this might be one that you could actually just solve in your head, but for literal equations, it works to use an example like this. And we know that the width is 6. So instead of substituting in all the values and then solving for L, we can just rewrite the equation now so that in any scenario, we could always find the length if we're given the perimeter and the width. So we're going to try that. Even though using these values, you may know the answer right now. So we have a few things happening here to L. Our length is first being multiplied by 2. 2 is that coefficient, which means there's 2 of this length. So it's multiplication. And then after we're multiplying, we're adding 2 of the width. So in terms of inverse operations, we're first multiplying and then we're adding. So to undo that, we can subtract 2W first from both sides. Now this over here gets a little tricky because we can't just say, oh, well, P minus 2W is going to be -1 of PW. That doesn't really make sense. These are not what we call like terms. So we represent this over here. The perimeter is P minus 2 of the width. And this is where our equation is at right now. So the next step here is that we need to now undo this multiplication of 2. And just like you've all told me before, we undo multiplication by dividing by 2. And we're going to divide not just this term, but the entire side by 2. So that now we have our big 1. And I'll actually erase this so we can see that we've now solved for the length. So now that we know whatever calculation we do is going to equal our length, we can substitute in our values, these values. So 24 minus 2 times 6, which some of you may know in your head. Oh, I'm sorry, the width is 3. I messed that up. The width in the original problem is 3. I multiplied it in advance. Okay, so we have 2 times 3, which is 6. Sorry, I kind of gave you that multiplication in the beginning. And then we're going to divide that entire side by 2. And this solution here should be our length. 24 minus 6 is 18. 18 divided by 2 is 9. For those of you who did it in your head in advance, I'm sorry that I completely gave you the wrong width, but you would have gotten a different value. So here we know this is true because if we go back to the beginning and say we have the length is 9, 2 of them, let me erase this, would be 18 here. And then 2 of our width, which in the original problem is 3, would be 6. This would actually total 24. So again, the concept is still the same. The difference here is that we're used to solving an equation with one variable. This equation actually has three. It has the P for perimeter, the L for length, and the W for width. And again, that formula, that's showing you the relationship between these values when we're talking about the perimeter of a rectangle. So for those of you that want some practice, these are really good practice problems. So this is a good time for you to take a picture of the screen, or if you can write anything down or screenshot it, to try some of these. Now, the formulas are given, and then they're asking you to solve for certain values. Okay, some of these might be a little bit more straightforward. Some may just involve operations you already know. And some may be a little bit more confusing to you. If they're more confusing to you and you're not really sure what to do, you can either send me an email or a direct message on Instagram and I can help you through. But that's all I wanted to show you. It's just a little extension from Friday. Does anyone have any questions, or is there anything that I can clarify in addition to what we already talked about? If no one has any questions, then we can end it here. I will be around all day for anyone who has any work that they're trying to do. On the website, www.mathwithmrsc.com, the most recent post is a list of all different things that we've learned in class with additional resources for you to practice. There's website links that have videos and questions for you to practice. So check those out, especially because we don't have school today or tomorrow. This, after we got the sound resolved, actually worked out pretty well. So if you want, I could do another one tomorrow because I'll be home, but I just need a topic. So if you have a topic that you want a little mini lesson on, send me a message. Send me a direct message, comment on any of my Instagram pictures, and let me know. And then we'll try it. We'll do it again tomorrow. So hopefully you all enjoyed our first live stream. And yeah, I'm going to chat with you all a little bit.